So in an equal amount of time, this line has to sweep through an equal amount of area. So as it's out here, it's sweeping through a lot of area because it's got, the line is longer, so it's moving. A short amount of rotation makes a lot of area, whereas a little bit of rotation here makes a little bit of area. So it's go much slower as it's further away from the sun, and much faster as it's closer. This is actually better at predicting things than Ptolemy's system, and it's so much simpler. This was the first actual breakthrough in planetary astronomy. This is what allowed the sun-centered universe, because remember, we're still talking about a sun-centered universe, not just a solar system. Sun-centered universe to really be accepted as actually better. Copernicus has some nice mathematical features, but he was essentially creating a Ptolemaic system with just the Earth at the center, which doesn't really work. This still has the same problems with religion and physics, but it's such a better predictor for what's going on in the sky that it still would have convinced most people. But we had even more things happen, piled it on, and such that it was inevitable that this would be accepted. We had Galileo. He looks at the sky and sees things rotating around Jupiter. This proves that the Earth is not, that the sky is not essentially that the Earth is not at the center of the universe, at least not for everything, because things are rotating around Jupiter. You also have observations of comets start to be taken seriously. Comets were seen as atmospheric phenomena for most of scientific history. But people started to show that they had to be further away than the moon through various techniques. And so that was showing that there was change in the heavens, which is a problem for the Aristotelian universe. And then you get Newton. Newton finally unites celestial mechanics and terrestrial mechanics for the first time. He said that all things follow the same laws, and that these laws can be expressed simply and mathematically. And his system is even better than Tycho Brahe's. And that's when you really start to get people accepting the sun-centered universe. And soon after that, people start saying even the sun might not be at the center of the universe. And you get all sorts of crazy stuff. Interesting footnote before I end this talk. The Aristotelian system was based on the idea that space is very important. Things fall to the center of the Earth. This was replaced by Newton, who created a system without this, his mechanics were based solely on mathematical equations with no real physical interpretation, and definitely space not being particularly important. Action at a distance. Then it's replaced by Einstein. Einstein says that that space is very important, and things fall to their natural place. It's a very different sort of natural place, but it's a natural place. And so, qualitatively, it's arguable that Einstein's system is closer to Aristotle's than it is to Newton's. So, what have we learned today? I hope to have shown you that the history of astronomy before Copernicus was not a bunch of people following what one old dead guy had said, even if it didn't really make sense. Instead, it was a vibrant community of scholars who were working with a very robust system in order to create the best possible tools for measuring the positions of planets in the sky. And the revolution instigated by Copernicus had a slow start. Copernicus was very much in the Ptolemaic tradition, which makes sense if you don't think of the Ptolemaic tradition as this dumb thing that you should have discarded immediately, but rather as an important historical influence and very good scientific body of work. Hopefully, I've shown you that the history of astronomy is something with a lot more going on to it, and that the views we get of it in science class are a little too simplified. And if we understand it in this way, we have a better appreciation for exactly what has gotten us to the point we are at in science, and we don't take the things we now believe for granted. And it gives us a better idea of the sorts of, our laws that we now have seem so set in stone. But hopefully this gives you an idea of how things that are as beautiful as the single epicycle, single difference system can just be blown out of the water. And so I hope to have presented a view of science to you that's much more fluid and much more robust than the one you may have had before. And if I've done that, then I've done my job. Thanks a lot.
That's all. I have a technical question,
Oh, yes.
actually. When we had the system that explained the imperial planets, was it believed the moon went around the Earth at this point? Or is the moon going around the sun?
The moon is also going around the sun, I believe. Well, actually, that may not be true. I'll get back to you on that one.
Was there a time, like, was there a specific point at which they started believing? Well, there obviously had to be a point at which they started believing.
It was definitely pretty concurrent with the Copernican revolution. I don't remember if it was in Copernicus' system itself or not. I should look that up. I should know that.
So
But it was either in Copernicus' system or those of his followers soon after.
So by the elliptical system, it was definitely the moon was around the Earth.
Well, it was around the Earth, and so was everything else. Yes.
No, but no. By the time the guy came up with the
Oh yes, yes,
by
yes,
the
yes.
time Kepler was that.
Yes. Any other questions? All right, that's all I have.
People should eat more fruit.